Okay, so in this video, we're going to learn how to convert from Cartesian to polar. Basically, Cartesian's your regular x's and y's. We want to think about what does polar mean. R's and thetas is what a polar is all about. R is basically the measure of the radius from the origin. In this case, we don't call it the origin anymore. If you're in polar, you call it the pole. Imagine that. And then you measure theta as usually you regularly would on like a unit circle. You measure it counterclockwise from the positive x-axis. What was the positive x-axis is now called the polar axis. So this one's called the polar axis. And this guy right here, the origin, is now called the pole. Okay, so that's the idea. So we're going to measure theta counterclockwise from that polar axis, and we're going to call the origin the pole, and the radius is the distance from there. So if you set this idea up here, basically, if I connect this up right here, this distance between the pole and the point is r, and then you make this cute little right triangle, and there you have theta right here, x, and y as the two sides of the triangle. So we can easily come up with some conversions, okay? If I know the x and y coordinates, say they were like 3 and 4, then you can easily find that hypotenuse of 5, and then the theta, you'd have to do some sort of tangent to be able to find theta, right? So x squared plus y squared equals r squared, right? Square root that. And tangent of theta would equal y over x. So if you knew x and y, you could easily solve for theta and solve for r here. If we want to go the other way, if I know r and theta, say r was 7 and theta was, 50 degrees, right? You could easily find x and y by thinking, okay, so if I want to know what x is, x over r is going to be cosine of theta. So that means x is r cosine theta. And same thing for sine. For sine of theta, you get the ratio of y over r, right? Opposite over hypotenuse. So y is r sine theta. So these are our conversions. If I know r and theta, I can easily find x and y. If I know x and y, I can easily find r and theta. All right. So that's just our conversion factors. So let's actually find a couple coordinate points, right? Let's say I have the point over here. That is, let's pick something over here. -3 and 4, right? That's my easy little piece here. So it makes a cute little triangle. -3, 4. Pythagorean theorem says 3 squared plus 4 squared, 9 plus 16. That's going to be 25. R is 5. Awesome. And then I need to find this angle. Not the reference triangle in there, but the actual angle right there. Something bigger than 90, less than 180. So if I did tan inverse of 4 over 3, right? Grab my calculator. Bring in my calculator. If I do, let me move this over there a little bit. I want to calculate theta, so tan inverse of -4 over 3, okay, that gives me an angle of -53 degrees. Well, that doesn't work. That doesn't look like -53 degrees. But we have to remember that when you do arctan, it could be tan inverse plus 180n. You might have to add 180 to put it in the correct quadrant. So let's add 180 and see if that makes sense. Ooh, 126 makes a lot more sense. Another option is you could find the angle that's actually in the triangle and then just do 180 minus that. It still works. So if we take this guy and plus 180, we got theta is about I forgot what it was already. 126.87, let's say. Degrees. So if you wanted to write this, right, xy was -3, 4, and I'm converting it to r is 5, and theta is 126.78 degrees. Okay, so that's just the easy conversion, and of course you could go the other way too. If I knew r and theta, right, I could easily convert back to x and y. Okay, let's say I had an angle, or r theta, that was, oh goodness, let's say 7 and 210 degrees, right? So that's my r theta. So I want to convert to x and y. 210 would be all the way over here. It'd have a little 30-degree reference angle. If this is 7, I want to find the x, and I want to find the y, okay? So what I could easily do is I could take this, right? X is going to equal 7 cosine of 210, right? Right from my unit circle, I know that cosine of 210 would be negative root 3 over 2. So that's -7 root 3 over 2. And that's some decimal, right? Y we could also find just as simply 7 sine of 210. And again, that would be 7 times sine of 210 would be, right for my unit circle, is negative 1/2. So that's negative 7/2. So using those two numbers, this converts to negative 7 root 3 over 2, comma, negative 7 over 2. And you can convert those to decimals to actually be able to plot them, but it makes sense that you get negatives for both, right? It's negative x, y, it's in third quadrant. All right, so what about, I mean, this doesn't seem like you could have a negative r value, right? So how would you plot a point with a negative r value? The idea here is if I had like negative 2 comma 30 degrees, what I would do is I would measure out my angle to be about 30 degrees like that, right? And then if this was 2 comma 30, 2 comma 30 would be here, a distance of 2 out, 2 comma 30. But if I want to have negative 2 as a radius, instead of going along that line in the positive direction, I'm going to come backwards, you know, exactly 180 degrees behind it and go out to here. This would be negative 2 comma 30 degrees. So basically it ends up being the mirror image in the opposite quadrant, not necessarily reflected over the x or y axes, but exactly 180 degrees later on the back end of that. It's like going backwards along that ray. Instead of going forwards 2, you're going to go backwards 2. So same idea. So we could come up with multiple r's and thetas for the same location. Okay, so if I started with 4 comma 120 degrees, we could say, okay, well that would plot over here, right? 120 degrees would end up being like this. I could also use, well, couldn't I use the negative version of that angle also? I could do 4 comma, a negative angle back to there would be negative 240. Okay, that would also work and plot in the exact same location. If I wanted to use a negative 4 for the r value, I'd need to find an angle over here. Because if I use an angle down in fourth quadrant and go backwards 4 along that ray, I'd get to negative 4 comma the angle that I want. So since this was, let's see here, this was a 30-degree reference and a 60 over here, I need a 60 over here and a 30 here. So negative 60 degrees. Because exactly 180 degrees away from negative 60 is positive 120, right? Or, you know, negative 4 comma, the positive version of that is 300, because exactly 180 degrees away from 300 is 120, okay? So if you're going to use a negative r value, you just find angles that are 180 degrees in the opposite quadrant away to be able to plot in the exact same location, okay? So that was my example. I actually did it above here, right? There's my 4 comma 120. Here's another point that would have a positive r but a negative theta. Here's a negative r and a positive theta. And here's one with a, oops. Oh, come on, grab all that. Come on, you can do it. Oh, did I grab it all? Come on. There it is. So there's one with a negative r and a negative theta. So I've got a combo of each. I use some positives and some negatives for my r's and for my thetas.